Welcome to Tech Studio 24. Our official handle is Tech Studio 24365. Today we are going to take a smooth ride through the code writing tour which results in development of a weather app. Imagine building a program that tells you the temperature, humidity, or even chances of rain. That's the power of coding. First, I want you to subscribe to this channel by hitting on the subscribe channel below to stay informed in Tech's how-to, for free. In this beginner-friendly tutorial, we're diving into the world of weather coding using Python. Python, a versatile and easy-to-learn language, combined with Visual Studio Code, a powerful code editor, provides the perfect toolkit. Whether you're completely new to coding or just starting with Python, this guide will equip you to build your own weather app. We'll break down each step clearly, from setting up your coding environment to understanding how to fetch real-time weather data. Get ready for a hands-on experience that will empower you to create something truly useful and impressive. Let's get started on your weather coding journey. Before we begin our coding adventure, let's gather our tools. Don't worry, we'll guide you through each installation process. First, we need Python itself, the language of our code. Head over to the official Python website and download the latest version suitable for your operating system. Next, we'll need a code editor, our digital workshop. Visual Studio Code, a free and feature-rich editor from Microsoft, is our weapon of choice. Download it from the Visual Studio Code website and install it. With Python and Visual Studio Code ready, we need a few more tools, libraries, to help us work with weather data. Don't be intimidated by the term libraries. They're simply collections of pre-written code that make our lives easier. We'll be using the requests library to fetch data from the internet and the JSON library to work with the data's format. We'll cover the installation process for these libraries within Visual Studio Code itself, making the process seamless. Now that we have our toolkit ready, let's move on to setting up our coding environment. Visual Studio Code is our coding playground where we'll write and run our weather program. Once you have it installed, launch the application. You'll be greeted by a welcoming interface ready for your commands. Let's get familiar with the layout. On the left side, you'll find the sidebar containing various icons. The topmost icon, resembling a sheet of paper, is the Explorer view. Click on it, and you'll see an option to open folder. Choose a location on your computer where you want to save your project and create a new folder. This folder will house all the files related to your weather application. Now, within Visual Studio Code, click on the new file icon. It looks like a sheet of paper with a plus sign, and name it weatherapp.py. The .py extension tells Visual Studio Code that we're working with a Python file. Congratulations, you've just created your first Python file within your project folder. Next, we'll install the necessary libraries and begin crafting our weather code. Now that we have our project set up in Visual Studio Code, let's install the essential libraries, requests, and JSON. Visual Studio Code makes this process a breeze with its integrated terminal. Click on Terminal and select New Terminal. Type the command python pip install requests. This tells pip to install the requests library. Repeat for the JSON library. Python pip install JSON. With both libraries installed, we're ready to communicate with weather APIs. Section 2. Requests, your data messenger. Imagine you want to order your favorite pizza. You wouldn't go to the pizzeria empty-handed, would you? You'd need to send them a request, specifying the type of pizza, toppings, and maybe even some extra cheese. Similarly, to get weather data, our code needs to send a request to a weather API. This is where the requests library comes in handy. It acts as our delivery person, carrying our data requests to the weather API and bringing back the delicious weather information we crave. Think of a weather API as a vast digital library holding up-to-date weather information from all around the globe. Our requests library, armed with the correct address, the API endpoint, fetches the data we need. In the next section, we'll learn how to structure this request using the requests library, specifying the location we're interested in and the type of weather data we seek. Get ready to send some weather requests. Section 3. JSON. Decoding the weather report. Imagine receiving a postcard from a friend written in a secret code. You wouldn't be able to understand their message without the key to decipher it. Similarly, weather APIs often send data in a format called JSON, JavaScript Object Notation. It's like a secret language that computers understand very well, but to us, it might look like a jumbled mess of text. Luckily, our JSON library acts as our translator, converting this JSON data into a format Python can easily work with: dictionaries. Dictionaries in Python are like organized containers with labels, keys, and their corresponding values. The JSON library takes the JSON data, identifies the keys, like temperature, humidity, or wind speed, and neatly organizes them with their values in a Python dictionary. This makes it incredibly easy for us to access specific weather information from the received data. We can simply ask our Python dictionary for the value associated with the temperature key, and voila, we have our temperature reading. Section 4. A peek into the future. We've laid the groundwork by setting up our project in Visual Studio Code and equipping ourselves with the requests and JSON libraries. We understand how requests acts as our messenger, fetching weather data from APIs, and how JSON decodes this data into a user-friendly format. In the next act, we'll roll up our sleeves and start writing the actual Python code to bring our weather app to life. Get ready to piece together the puzzle, using these libraries to send requests, receive data, and extract valuable weather information. Your journey to becoming a weather wizard is just beginning. Let's create a home for our weather project, a place to keep all our code neat and organized. Think of it like a digital toolbox where we'll store our Python files, libraries, and all the bits and pieces that make our app work. Navigate to your computer's File Explorer. You can usually find this by clicking the folder icon on your taskbar or by searching for File Explorer in your Start menu. Once you're in, choose a location for your project. It could be your Documents folder, your desktop, or any other place that makes sense to you. Inside your chosen location, create a new folder and give it a descriptive name like Weather App or something equally creative. This folder will be our project's headquarters, housing all the files we create. Now, let's open this folder in Visual Studio Code. Remember that welcoming interface we saw earlier? Click on the Open Folder option in the Explorer view and select the Weather App folder you just created. Now you should see your folder in Visual Studio Code sidebar, ready for us to start filling it with code. Now that our Weather App folder is open in Visual Studio Code, let's create a file to hold our Python code. Remember, organization is key. Click on the new file icon in the Explorer view of Visual Studio Code. You'll see a prompt to enter a file name. Let's call it weatherapp.py. The .py at the end of the file name tells Visual Studio Code that this is a Python file, ensuring it uses the correct syntax highlighting and tools. Hit enter and voila! You now have a blank Python file open and ready for your commands. As our project grows, we might want to add more files for different functionalities or to store data. Keeping them organized within our Weather App folder will prevent any digital clutter. Think of it like arranging tools in a toolbox. Everything has its place for easy access. Now that we have our project folder and main Python file set up, let's talk about virtual environments and how they contribute to a clutter-free coding experience. Imagine you're a chef preparing a new dish. You wouldn't want ingredients from previous recipes mixing with your current creation, would you? Similarly, in Python, we use virtual environments to create isolated spaces for our projects. Think of a virtual environment as a dedicated cooking station for your Python project. It ensures that the libraries and versions you install for one project don't clash with those of another. This is especially important when working on multiple projects with potentially conflicting requirements. Setting up a virtual environment is simple in Visual Studio Code. Click on the View menu at the top, then select Terminal to open the integrated terminal. Once the terminal is open, type the following command and press Enter Python. venv.venv. This command creates a virtual environment in your project folder. You'll notice a new folder named .venv appear in your Weather app folder. This is where all the magic happens. To activate your virtual environment, type the following command in the terminal. venv/scripts/activate. You'll see your terminal prompt change, indicating you're now inside the virtual environment. Any libraries you install from now on will be contained within this environment, keeping your project's dependencies clean and isolated. Section 4. Ready, Set, Code. With our project folder structured, our main Python file ready, and our virtual environment activated, we're all set to dive into the exciting part, writing the code for our weather application. We've laid a strong foundation, ensuring our project is organized and our dependencies are managed. Now we can focus on crafting the logic to fetch, process, and display real-time weather information. In the next act, we'll put our requests and JSON libraries to work, constructing the code that will bring our weather app to life. Get ready to unleash your inner coder and experience the satisfaction of building something from scratch. The weather's calling, and we're ready to answer. Section 1. Importing our tools. Let's start by importing the libraries we'll need, like gathering ingredients before we start cooking. At the top of your weatherapp.py file, type the following Python import requests. Import JSON. This code tells Python to import the requests and JSON libraries, making their functionalities available to us. Think of it as inviting these powerful tools into our coding kitchen. Now, we can use the functions and methods provided by these libraries to fetch weather data from an API and decode it into a format we can understand. Remember the requests library, our data messenger? We'll use it to construct and send a request to a weather API. The JSON library, our translator, will then help us make sense of the response we receive. With our tools ready, let's move on to fetching some real-time weather data. Section 2. Fetching weather. Data with requests. To get weather information, we need to send a request to a weather API. First, we need the API's URL. We'll use OpenWeatherMaps API. Sign up for a free account to get an API key. Add the following code to your weatherapp.py file. API key x your API key base. URL equals http api.openweathermap.org. Data 2.5. Weather. City name equals input. Enter city name. Complete URL equals base URL plus appid plus API key plus enqueue plus city name response equals requests. Get complete URL. Now, we have the weather data stored in the response variable. Section 3. Extracting information from JSON. The response we received from the API is in JSON format, like a letter written in a code. Let's use the JSON library to decode it. Add the following code below the previous lines. This line converts the JSON data into a Python dictionary and stores it in the data variable. Now, we can access specific weather information using keys. Think of a dictionary as a treasure chest with labels on each compartment. The labels are the keys, and the treasures inside are the values. We can access the values by using their corresponding keys. For example, to get the temperature, we can use. Let's see how to retrieve and display various weather parameters in the next section. Section 4. Displaying the weather report. Now for the exciting part. Displaying the weather information. Add the following code to your weatherapp.py file. This code checks if the city was found, and then extracts specific weather details like temperature, humidity, pressure, and weather description from the data dictionary. Finally, it prints this information in a user-friendly format. Congratulations! You've successfully fetched, processed, and displayed weather data using Python. In the next section, we will run our newly created weather app. Section 5. Running your weather app. It's time to test our creation. Save your weatherapp.py file. Then, navigate to the terminal in Visual Studio Code. Remember, it should still be open in the virtual environment, and type the following command. Press Enter, and the program will prompt you to enter a city name. Type the city you want the weather for, and press Enter again. Voila! Your very own weather app will spring to life, displaying the current weather conditions for the city you entered. You've successfully built a weather app in Python. Feel free to experiment with different city names. In the next section, we'll take a step back and understand the code we've written. Section 6. Understanding the code. Let's break down the code we've written to solidify our understanding. First, we started by importing the requests and JSON libraries, giving us access to their powerful tools for fetching and decoding data. Second, we used the requests library to send a GET request to the OpenWeatherMap API, retrieving weather data for the city entered by the user. Third, we utilized the JSON library to convert the JSON response into a Python dictionary, making it easy to extract specific weather information. Fourth, we accessed the desired weather details from the dictionary using their respective keys and presented them in a clear format. Understanding these steps empowers you to modify and enhance your weather app further. You could explore additional data parameters offered by the API, customize the output format, or even add features like forecasting future weather conditions. This is just the beginning of your journey into the world of weather coding. Section 1. When cities go missing. Handling city not found. You've written your weather app, entered a city name, and hit Enter. But instead of a sunny forecast, you're met with a disheartening city not found message. Don't worry, this is a common hiccup, especially when working with location-based data. One possibility is a simple misspelling. Double-check the city name you entered, ensuring it's spelled correctly and matches the API's database. Even a small typo can throw things off. Another possibility is that the API's database doesn't recognize the city you entered. This could happen with smaller towns or cities with unconventional spellings. Try entering a larger, more well-known city nearby to see if the API recognizes it. If you're still encountering issues, the API's documentation is your best friend. It often includes details about city naming conventions, potential limitations, and troubleshooting tips for location-related errors. Section 2. Lost in translation. Decoding JSON errors. You've successfully fetched data from the API, but as you try to extract information, you're greeted by a JSON decode error. It's like receiving a postcard in a language you don't understand. This error usually means the data received isn't in the expected JSON format. One common culprit is an issue with the API itself. Servers can sometimes have hiccups, resulting in incomplete or malformed data being sent. Try running your code again after a few minutes. If the problem persists, it might be a temporary issue on the API's end. Another possibility is that the API's response format has changed. APIs undergo updates, and sometimes these updates include modifications to how data is structured. Check the API's documentation for any recent changes to the response format and adjust your code accordingly. Remember, the JSON library expects data in a specific format. Any deviations can lead to decoding errors. Carefully examine the data received from the API to ensure it aligns with the JSON library's requirements. Double-check your API key. Your code refuses to fetch data, throwing errors related to authentication or invalid API keys. It's like trying to unlock a door with the wrong key. Frustrating. Ensure you've replaced the placeholder your API key with your actual API key from OpenWeatherMap. Even a single incorrect character will render them invalid. Double-check that it's still valid. API keys often have expiration dates or usage limits. Verify your API key's status. Generate a new one if it has expired or exceeded its limits. Ensure you're using the correct API endpoint. Using the wrong endpoint can lead to authentication errors. Refer to the API documentation to confirm you're using the appropriate endpoint. Section 4. Internet interruptions. Checking your connection. You're eagerly waiting for the weather report, but your code seems stuck, hanging indefinitely without producing any output. Before blaming the code, it's wise to check a fundamental element: your internet connection. Weather apps rely on fetching data from online APIs, and a stable internet connection is crucial for this communication. Start by checking if you're connected to the internet. A simple way is to open a web browser and try loading a website. If the website loads, your connection is likely fine. If not, troubleshoot your internet connection. Restart your router, check your network settings, or contact your internet service provider if needed. Even with a working internet connection, temporary network glitches can occur. Try running your code again after a few moments. If the issue persists, it might be a temporary network hiccup. Remember, fetching data from APIs involves sending requests and receiving responses. A slow or unstable internet connection can significantly impact this communication, leading to delays or timeouts. Section 5. Debugging like a pro. Reading error messages. Encountering errors is a natural part of coding. Instead of getting discouraged, view them as opportunities to learn and improve. Error messages, though seemingly cryptic, are valuable clues pointing to what went wrong. Visual Studio Code is excellent at highlighting errors in your code. Red underlines usually indicate syntax errors, like typos or incorrect punctuation. Hovering over these underlines often provides helpful explanations. When you run your code and an error occurs, the terminal will display an error message. Don't shy away from these messages. Read them carefully, as they often provide insights into the problem's nature and location. Pay attention to the error type. For example, type error, key error, connection error, and the line number indicated. These are crucial clues for pinpointing the issue. If the error message isn't clear, try searching for it online. Websites like Stack Overflow are treasure troves of coding knowledge, often providing explanations and solutions to common errors. Section 1. Congratulations, Weather Wizard, you've done it. You've journeyed through the ins and outs of weather coding in Python, transforming from a coding novice to a weather wizard wielding the power of data at your fingertips. Take a moment to appreciate how far you've come, from setting up your coding environment to witnessing your very own weather app come to life in Visual Studio Code. Recall those first steps, installing Python and Visual Studio Code, perhaps a bit uncertain of what lay ahead. You embraced the challenge, setting up your project folder, creating your Python file, and even mastering the art of virtual environments to keep your code organized and pristine. Remember the thrill of sending your first request to the Open Weather Map API, your code venturing into the vast digital landscape to retrieve real-time weather data? You deciphered the secrets of JSON, translating it from a cryptic code into a format Python could understand, extracting valuable insights about temperature, humidity, wind speed, and more. You've not only learned, but truly conquered. Section 2. Embracing the coding journey. As you stand at this milestone, remember that coding, like any skill worth mastering, is an ongoing journey. There will be moments of triumph, where your code flows effortlessly, and moments of head-scratching, where errors seem to lurk around every corner. Embrace both as opportunities for growth. The challenges you overcome solidify your understanding and equip you with the problem-solving skills essential for any coder. Remember those troubleshooting tips, those strategies for deciphering cryptic error messages? Each hurdle you've cleared has added a valuable tool to your coding arsenal. Don't be afraid to experiment, to tweak your code, to explore new features, and to push the boundaries of what you thought possible. Curiosity is the engine of innovation in the coding world. The more you explore, the more you'll discover the boundless possibilities that Python and the world of APIs offer. Section 3. Exploring new horizons. With the foundations of weather coding firmly in place, a world of opportunities awaits. Consider enhancing your app with more sophisticated features. Perhaps you could incorporate weather icons to visually represent the forecast, or add a feature to display a 5-day forecast, allowing users to plan their week ahead. Delve deeper into data visualization libraries like Matplotlib or Seaborn. Imagine presenting the weather data not just as text, but as visually appealing graphs and charts, making trends and patterns easier to grasp. Venture beyond OpenWeatherMap and explore other weather APIs, each offering a unique set of data points and functionalities. You could incorporate air quality data, UV index information, or even pollen counts for allergy sufferers. The possibilities are as vast as the weather itself. Remember, this tutorial has equipped you with the knowledge and skills to navigate the world of weather coding. Now, it's your turn to take the reins, to experiment, to create, and to let your coding journey unfold.